So today we are going to see the design of counterfeit retaining wall. So first, what is counterfeit retaining wall? A counterfeit retaining wall is a cantilever wall with counterforts. Okay, it is similar to cantilever retaining wall only, but it has counterforts. Okay, or buttresses, but both are different. Counterfeit retaining wall and buttress retaining wall are different. Okay, in counterfeit retaining wall, the counterforts are provided at the back side of the retaining wall, but in buttress retaining wall, the buttresses are provided. Okay, the same counterforts only, but we are naming it as buttresses. That is provided at the front side of the retaining wall. Okay, so this is the image for counterfeit retaining wall. Okay, so this is the backfill. So that means this is the back side of the cantilever retaining wall, and this is the face of the wall. Okay, in this, we are providing the counterforts at the back side of the retaining wall. Okay, and in this diagram, here we are having backfill. That means this is the back side. Okay, and this side is the face of the wall, front side of the retaining wall. Here we are providing the counterforts. Okay, so we are naming this counterforts as a buttress. Okay, hence this is a buttress retaining wall, and this one is we called as counterfort retaining wall. Next, we'll see the design of the counterfort retaining wall. Okay, so this is the design data. This is a counterfeit retaining wall based on the following data. Height of the wall above ground level 6 meter. Safe bearing capacity of the soil is 160 kilonewton per meter square. Angle of internal friction 33 degree. Density of soil as 16 kilonewton per meter cube. Spacing of counterforts 3 meter center to center. So spacing means this distance. Okay, spacing between two counterfoot center to center distance is 3 meter. Okay, so this is one counterfoot and this one is another counterfoot. The distance between these two counterfoots is 3 meter in this question. Okay, so adopt M20 grade concrete and Fe 415 HYSD bars. So draw the following views showing the reinforcement details. Okay, so sectional elevation midway between counterforts, sectional elevation through counterforts, then sectional plan at base of counterforts. We have to draw 3 diagrams. So first step, dimensions of the retaining wall. As it is in cantilever retaining wall, the same first step is dimensions of retaining wall. So minimum depth of foundation. First, we have to calculate the minimum depth of foundation. Okay, the formula is P by W into 1 minus sine phi divided by 1 plus sine phi the whole square. Okay, so P is a safe bearing capacity of the soil, 160 kilonewton per meter cube. Okay, and W is density of soil. In the question, they gave it as 16. Okay, phi value we know 33 degree. In the question, they gave. Okay, so 1 minus sine 33 degree divided by 1 plus sine 33 degree, we'll get the value as 1 by 3. Okay, so finally, after simplification of this, we'll get the minimum depth of foundation as 1.11 meter. Okay, so we are taking the depth of foundation as 1.2 meter. We are rounding this value to 1.2 meter. So we provide depth of foundation as 1.2 meter. So after that, overall height of the wall 6 plus 1.2. We know the stem of the retaining wall. In question, they gave the stem height of the stem as 6 meter. So plus depth of foundation. Okay, so gives the overall height of the wall. So that is 7.2 meter. So after that, we have to calculate the thickness of the base slab. Okay, so thickness of base slab in previous problem. Okay, that is design of cantilever retaining wall. There we used the formula h by 12, but here the formula is changing. There the formula is 2LH. Okay, so 2 into 3. L is 3. Here the L is the spacing between the counterfoots. Okay, we are using that distance. So 2 into 3 into H, capital H, so 7.2. So 2 into 3 into 7.2. We are getting 43.2 centimeter. Okay, so it is an empirical formula. We are substituting L in meter. Okay, so H also in meter, but the value we are getting in centimeter. Okay, so this is an empirical formula. We have to substitute in meter, but we are getting final result is in centimeter. So 43.2 centimeter. Okay, so that means 432 mm. Okay, so we are rounding this value to 450 mm. So provide 450 mm thick base slab. Okay, the thickness of base slab is 450 mm. So after that, we are calculating base width. Okay, so the base width should be in the range of 0.6 h to 0.7 h. Okay, the h value is 7.2. So therefore, 0.6 into 7.2, we are getting 4.32 meter, and 0.7 h, 0.7 into 7.2, we are getting 5.04 meter. Okay, so the base width should be in the range of 4.32 meter to 5.04 meter. So we are providing the base width as 4.5 meter. Okay, so adopt base width as 4.5 meter. So after that, we are calculating the toe projection, toe slab projection. Okay, so toe slab projection is 1/4 of the base width. Okay, so 1/4 of 4.5 meter. So we are getting 1.1 meter. Okay, so this diagram shows, okay, the toe slab, we are getting 1.1 meter, but we are providing 1 meter as the width of toe slab. Okay, so overall base width is 4.5 meter, 1 meter plus 2.2 meter plus 3.28. Okay, so we are getting 4.5 meter overall base width, and the thickness of base slab is 0.45 meter. Okay, that is 450 mm. Okay, so step 2 is design of stem. Okay, uh, first we have to calculate the pressure intensity at the base. Okay, for that the formula is WH into 1 minus sine phi divided by 1 plus sine phi. Okay, so where H is equal to height of the stem. Okay, actual height above the base slab. Well, we know the overall height is 7.2 meters. So 7.2 minus thickness of the base slab, that is 450 mm, 0.45 meter. 7.2 minus 0.45. So we are getting 6.75 meter. This is the actual height of the stem. You can see in this diagram. Okay, so height of the stem above the ground level is 6 meter. Okay, and minimum depth of foundation is 1.2 meter. The thickness of base slab, okay, this one, thickness of base slab is 450 mm or 0.45 meter. So we have to calculate the actual height of the stem. So actual height of the stem is 7.2 minus thickness of base slab, that is 0.45. So 7.2 minus 4.5, we are getting 6.75 meter. Okay, 6.75 meter. So after that, we are calculating the pressure intensity. Okay, so 16 into 6.75 into 1 by 3. Okay, 16 is a W. Okay, density of soil is 16 into H is 6.75. Then 1 minus sine phi divided by 1 plus sine phi gives 1 by 3. Okay, so after multiplication of these, we are getting the pressure intensity as 36 kilonewton per meter square. Okay, so after knowing pressure intensity, we have to calculate maximum working moment. Okay, so maximum working moment. So this is a fixed support. Okay, so fixed end support, the moment formula, fixed end moment formula is WL square by 12. Okay, so by using that formula, 36 into 3 square. Okay, L is 3 meter, the spacing between the counterfeits. We are using that distance. So 36 into 3 square by 12, we are getting as 27 kilonewton meter. So maximum working moment as 27 kilonewton meter. So after that, factored moment mu. So 1.5 into 27, we are getting factored moment as 40.5 kilonewton meter. So after calculating the moment, next we are calculating the effective depth. Okay, so D equal to square root of, we know this formula, mu is equal to 0.138 FCK BD square. From that formula only we are getting this. D is equal to square root of mu divided by 0.138 FCKB. That is equal to mu value we know 40.5 kilonewton meter. So we are substituting in Newton mm. 40.5 into 10 power 6 Newton mm divided by 0.138. FCK value is 20. In the question, they gave the grade of concrete as 20 into B. B, we are substituting as a 1 meter. Okay, 1000 mm. 10 power 3 is 1000. For so 1 meter length, we are calculating. So we are getting the D value, effective depth as a 121 mm. Okay, so after that, we are considering this as an under-reinforced section and to provide a suitable thickness to resist design shear at the base of stem. So adopt an overall thickness of 220 mm constant up to the top. Okay. So we are providing the stem thickness as a 220 mm constant up to the top. But in previous design, that is in design of cantilever retaining wall, thickness of stem is not a constant one. It was tapered at the top. But here it is a constant thickness only from base to the top. Okay. So after adopting the thickness as a 220 mm, next we are choosing the effective depth as 175 mm. Okay, we get the effective depth as a 121 mm, but we are choosing the effective depth as 175 mm. Okay, so therefore the reinforcement calculation is okay. So mu is equal to 0.8. So by using that formula, so mu value we know 40.5 kilonewton meter. So 40.5 into 10 power 6, that is equal to 0.87 Fy AST. Fy value 415. The question they gave AST into D value 175 into 1 minus F 415 into AST divided by 10 power 3 into 175 into 20. Okay, so for 1 meter length we are calculating. So we are getting AST as 700 mm square. Okay, so we are providing 12 mm dia bars at 150 mm center to center. We are getting the for that the AST value is 754 mm square, 754, which is more than 700. So hence it is okay. So after calculating main reinforcement, next we are calculating distribution reinforcement. So distribution reinforcement is 0.12 percentage of cross section, that is BD. So 0.12 percentage is 0.0012 into BD. Okay, so uh, with this 220 mm, okay, into for 1 meter length, so into 1000. So we are getting 264 mm square per meter. Distribution reinforcement is 264 mm square. So adopt 6 mm dia bars at 200 mm center to center. For this, the AST value is 283, which is more than 64, hence it is okay. So this is the diagram of the counterfeit retaining wall, which has dimensions also. Okay, so the overall height, once again, I'm telling the dimensions and all. Okay, the overall height of the counterfeit retaining wall is 7.2 meter, and height above the ground level is 6 meter. Okay, so minimum depth of foundation height is 1.2 meter, and thickness of base slab. Okay, totally we'll call this slab as a base slab, including toe slab, E slab, heel, everything we'll call it as a base slab. So thickness of base slab as 450 mm or 0.45 meter, and width of base slab. Okay, this one is the width. Okay, width of base slab is 4.5 meter. Okay, here we are providing the thickness of the stem is constant from base to the top 220 mm. Okay, we are providing the thickness of the stem as a 220 mm. So thickness of stem is 220 mm. Okay, so after that, step number 3 is stability calculations. Okay, so we already saw the stability calculation in a cantilever retaining wall itself. It's the same like that only. Okay, so we have to consider forces acting on the counterfeit retaining wall. So what are all the forces acting on counterfeit retaining wall means W1, W2, and W3. So W1 is the self weight of the stem. Okay, here this is W1. So W1 is self weight of stem. So W2 is the self weight of the base slab, okay, total slab, and W3 is the backfill weight, okay, not counterfeit weight, backfill weight, okay. So weight of the backfill or earth soil. So, so in stability calculation, first we are considering W1. Sorry. So W1 is equal to. So it is a totally rectangle only. So for us it is very easy. So 0.22 meter, that is the width of the stem. So 0.22 into height is 6.75 into 24. 24 is the unit weight of concrete, okay, which gives the magnitude of the load, that is 35.64 kilonewton. Then center of the gravity distance from A. Okay, from here only, from A only we are taking the moment. Okay, so center of the gravity distance is this distance will come 3.28 distance will come, and the weight is acting in this portion only. Self weight of the cell is 2.220 mm only. So at the center only, this 35.64 kilonewton act. Okay, so 220 divided by 2, so that is 110 mm. Okay, so 3.28 plus 0.11 meter. So we'll get center this distance is 3.39 meter. Okay, the stability calculation, we are taking moment at the point A, yield point A. So 35.64 into 3.39, we are getting movement at point A as 120.80 kilonewton meter. Similarly, W2. So W2 is the base slab. Okay, self weight of the base slab. So base thickness is 0.45 meter into width of the base slab is 4.5 meter into concrete only. Okay, so unit weight of concrete 24. So 0.45 into 4.5 into 24. We are getting the magnitude of the load as 48.6 kilonewton. Okay, and now we are taking the moment for this weight also at point A. Okay, so this weight is acting at the center of the base slab. Okay, the center means 4.5 divided by 2. Okay, the base width is 4.5 meter. So center point is 4.5 divided by 2. So we are getting 2.25 meter. Okay, so therefore the moment is 48.6 into 2.25. So moment about point A is at a 9.35 kilonewton meter. Okay, after calculating W1, W2, next we are calculating for W3. Okay, so W3 is equal to 3.28. Okay, that is width of the eel. Okay, so for that portion only the backfill is active. So 3.28 into 6.75. 6.75 is the height. Okay, for that height only we are storing the backfill. So we have to consider that height also 6.75. So 3.28 into 6.75 into 16. 16 is density of the soil. Okay, so we are filling soil only in this portion. So we have to consider that. Okay, so into 16. So 3.28 into 6.75 into 16. We are getting the magnitude of load as 354.24 kilonewton. Okay, so this soil, okay, this weight acts at the center of the eel slab. Okay, so width of the eel is 3.28. So center means 3.28 divided by 2. So we are getting 3.28 divided by 2. We are getting as 1.64. Okay, from A, the center point is center distance is 1.64. Okay, so therefore the movement is 354.24 into 1.64. We are getting the moment at about point A is 580.95 kilonewton meter. Okay, so not only this pressure, the earth pressure will also act lateral direction. Okay, so we have to consider that also. The formula is Ka into WH cube by 6. Okay, so moment of earth pressure is Ka into. Okay, in the book they mentioned as equal to symbol here. No equal to, it comes multiplication symbol only. So Ka into WH cube by 6, that is equal to Ka value 1 by 3. Already we calculated Ka is nothing but 1 minus sin phi divided by 1 plus sin phi. Okay, so we know that. So Ka is 1 by 3 into W value 16. Okay, density of soil 16 kilonewton per meter. So 16 into 16 into h cube. Okay, so h is overall height. So 7.2 cube divided by 6. Okay, so this value is 331.77 kilonewton meter. Okay, so after calculating the moments, okay, now we are summing of loads and moments. Okay, so summation of load is 438.49 kilonewton, and summation of moment is 1142.87 kilonewton. Okay, so we have to locate the resultant load. Okay, this is the resultant load. We have to locate this resultant load where it is acting. Okay, so next step is that only. So next step, the distance of point of application of the resultant from point A. Okay, so we calculated the moment up to point A only, about point A only. So from point A only, we are locating where the resultant is acting. Okay, so for that, Z is equal to summation M divided by summation W. Okay, summation M is summation of moments, that is 1142.87. divided by summation W, that is summation of magnitude of loads, that is 438.49. So it gives 2.66 meter. Okay. So the resultant load is acting at 2.66 meter from point A. Okay. So there is a eccentricity. We have to calculate that. Okay. So therefore, eccentricity E equal to Z minus B by 2. Z is 2.66. So 2.66 minus B by 2. B is nothing but a width of base slab. So 2.66 minus 4.5 divided by 2. So we are getting a 0.41 meter. Okay, so 0.41 meter is the eccentricity. Next, we are checking the eccentricity is the limit. Okay, so eccentricity should be less than B by 6. So that we are calculating B by 6. So B 4.5 divided by 6, we are getting a 0.75 meter. So definitely 0.41 is less than 0.75 meter. Hence it is okay. E is less than B by 6. So after that, we are calculating the maximum and minimum pressure at the base. Okay, so we know that formula. So maximum pressure is equal to summation W divided by B into 1 plus 6E divided by B. Okay, summation W 438.49 divided by B width of base slab 4.5 into 1 plus 6E. E is already we calculated 0.41 meter eccentricity. So 6 into 0.41 divided by B is width of base slab 4.5. Okay, so we're getting maximum pressure as 150 kilonewton per meter square and minimum pressure. Okay, the only difference is minus here. So the minimum pressure is 45 kilonewton per meter square. Okay, so the maximum intensity of pressure does not exceed the permissible value of 160, that is soil pressure. Safe bearing capacity of soil in the question they gave us 160. It should not exceed the maximum intensity of pressure, should not exceed the safe bearing capacity of pressure. So for our the value is 150. So it is within the limit. Hence, okay. And next, we are drawing the pressure distribution diagram. Okay, so we all know the maximum pressure will come at the toe side only, and minimum pressure will come at the heel side only. So for that, we are calculating the we are drawing the diagram like this. Okay, so in toe portion, we are having the maximum pressure 150 kilonewton per meter square, and then heel portion, we are drawing the minimum pressure as 145 kilonewton per meter square. Okay, so in between places and all, we have to calculate the pressure by using interpolation method. Okay, so at point F, the pressure is 126.6 kilonewton per meter square. Similarly, at point G, we have to calculate by using interpolation method. So far, we design the dimensions of the retaining wall, design of stem, okay, and stability calculation. So three steps only so far we completed. Do you have any doubt in this?